All right, number 1, it says to find the domain and the range of the function represented by the graph. Okay, I notice that I have 4 dots on this graph, so I'm actually going to list those 4 points. The first point is 0, 0. The second point is 1, 0. The third point is 2, 0. And the fourth point is 3, 0. So my domain is going to be all of the x values, and my range will be all of the y values. So my x values are 0, 1, 2, 3, and my range, all of the y values are only 0, so I just have one answer for that. Okay, number 2, the domain and range. This time it is given to us connected graph, so we are going to do this a little bit differently. So if I had my toothpicks out, I'm just going to, my left toothpick would go out to the left that far, and my right toothpick would go this far. I'm looking at the x values, so my furthest to the left x value is 1, my furthest to the right x value is 4, and if you recall, the way that we will write that is like that. And then for my range, I'm going to look at how far down does it go to how far up it goes, and I'm looking at y values. So how far down does it go? It goes down to -2, and then it goes up to 1. So in the y direction, it ranges between -2 and 1, so that would be my range. Right, number 3, the amount of money you collect after washing X cars at a car wash and asking for donations is represented by the function y equals 6x plus 17. Is the domain discrete or continuous? Well, discrete means we would only have whole numbers. Continuous means our answer could contain decimals and fractions. And we're talking about the domain, which would be the number of cars. Okay, so the number of cars, would that be discrete or continuous? I am going to say that it's going to be discrete, and the reason that it is, we are only going to wash whole cars. So only whole cars will be washed. A person would not be happy if I washed a sixth of their car or a tenth of their car. They want the whole car washed. Alrighty, number 4, it says to find the value of x so that the function has the given value. So this one, it says m of x equals x plus 3, m of x equals 9. So just how we did in some of our other examples, we want this 9, that needs to be our answer. So that's not the x value, that's our answer. So we're going to put 9 equals x plus 3. We're going to solve this equation. We'll subtract 3 from both sides, and when I do that, I get x is equal to 6, which is choice D. Okay, number 5, determine whether the relation is a function and then explain. So in this one, to tell whether there's a function, I'm going to look at all the inputs. We have inputs of -3, -2, 0, 1, and 3. None of those items are the same, so it doesn't matter to me whether any of the prices are the same. So I'm going to say, yes, this is a function. I'm going to see that every input has exactly one output. We don't have any of those inputs. It doesn't say like 1, 4, and 1, 8 or anything like that. And then number 6, again, we're looking at is it a function or not. -1 goes to 3, 0 goes to 2, 1 goes to 1, 2 goes to 0, 1 goes to 2. I see a little bit of an issue right here, because right here 1 has an output of 1 and 1 also has an output of 2. That is not okay. So no, this is not a function. I'm going to say that 1 has 2 outputs, and that is not okay at all.